Welcome everybody, good afternoon. Hope you've all got a cup of tea, a sandwich, getting comfy, just for a really quick 15 minutes of hopefully something that's super interesting. We've talked about this, Heba, for ages on a Zoom. I don't know how we're going to cover stuff in 15 minutes, but we're going to try our best. Yeah. So you've all signed up for the webinar, so you know what it's about, but we're talking about the use of robotic exoskeletons and upper limb rehabilitation. And I'm so thrilled because we have a proper real expert in our midst. We've got Heba Lakany, who's a leading researcher in this area in upper limb exoskeleton technology and a lecturer at the University of Liverpool. Heba also works with Stroke Mandible Spinal Research, which is a brilliant charity, and I'll make sure all of this is linked when we send out the stuff afterwards, so you'll be able to go onto the website and click through to all the links to see these organisations. But she's a very busy lady, basically, juggles a million different commitments. So thank you so much for making time for us, Heba. I really appreciate it.
Thanks for having me.
No, not at all. So as I said, we had a really long conversation about kind of how robotic exoskeletons for upper limb is kind of developing and what's going on, because to be honest with you, I was a wee bit clueless, or well, less of a clue than I would have liked about this area, because in our field, you know, we work with people that are catastrophically injured, and most of the people watching this webinar will be the same or will be injured themselves, and we've all seen a lot of lower limb exoskeletons, but less so of the upper limb stuff. And I thought it would just be helpful to start off with you telling us a little bit about why that might be the case and why the upper limb stuff isn't so prevalent.
Right, okay, so that's an excellent question. So you're right, there are lots of, well, not lots, but there's quite a few at the moment commercially available lower limb exoskeletons that are untethered, so people can wear them and move about, and whereas there are fewer ones in upper limb. And the reason for that is with lower limb, it's so walking, for example, is a very definite sequence of events. So the kinematic model, so kinematic meaning the movement, is quite well defined. So for example, if we're walking, then say a gait cycle will start with a heel strike, and then the foot goes flat, and then slowly the heel comes off, and as long as when the toe also comes off, then the leg starts to swing. And while it's swinging, the other leg is in stance and preparing to do an alternating between one leg and the other. So this is a very determined sequence of events that can be easily programmed in a robotic rehabilitation exoskeleton. Whereas with your arms, now there isn't this alternating at all, and it depends on what application you're doing. So with walking, if you're walking to the shops, it's very similar to walking to work. It's the same sequence of events. But when you're doing with something with your arms or hands, then depends on what exactly you're doing and whether it's a single-handed task or you know, you use both hands, a bimanual task, and the intricacy or the of your fingers doing fine motor control, that makes it a very complex model, kinematic model to really code in a robotic orthosis.
So it's the technology, isn't it? It's the complexity of the development, basically.
Exactly, yeah, and the number of degrees of freedom. So this is the movements that you can do in a plane are far more than the lower limb. And the fact that they are exclusively detached from each other, then that makes it really complex.
Yeah, and I was thinking a little bit about our last meeting. Obviously, before we were doing this, we've had a chat about all this stuff, and I was thinking about what we were saying when somebody has a spinal cord injury and don't have use of their legs anymore. The kind of ultimate goal is to walk, but actually there are so many tasks that we all take for granted all the time that you do with your hand, just as I'm swinging my hand around here, you know, that we take for granted. And it got me thinking a lot about kind of how the the technology would feed into rehab, all different kind of aspects of rehab, and we'll come back to that point. But and I was thinking about the types of people that might benefit from the upper limb technology, and maybe that would be a good kind of place to start with this question. Who is this technology intended for, and also, is there kind of a base level of function required to use it? You know, can someone with a really high level spinal cord injury use this stuff?
So this technology is targeted at anyone with weakness or paresis in their upper limbs. So this could be a spinal cord injured, high-level spinal cord injured survivor, stroke patient, brachial plexus injured, you know, in a accident. So it could be useful for all these people, but depending on the technology and what the exoskeleton is built as, it will require a particular profile of that, you know, a particular presentation that it will cater for. So some of the available exoskeletons, for example, don't have a robotic shoulder, and hence anyone with a subluxed or unable to support their shoulder then will not benefit essentially from that type of device, and they will require a different device for that.
Yeah, so super complex and super bespoke depending on the individual.
In a way, yeah, because even within the same sort of a number of stroke survivors will have different presentation than another one.
Of course.
Yeah, so it requires customization. You're right. Yeah.
And we see that all the time with brain injury. You know, someone could have exactly the same type of brain injury as someone else, and their presentation is totally different. It's the same with these neurological problems, you know, affect the paresis as well. So, and I wanted to talk a little bit, because this is kind of the important bit. And what I wanted to know about most, which was, you know, what's available at the moment, because, you know, I've been to lots of demos where we see lower limb exoskeletons, but I haven't been to one where there's an upper limb. So what's available at the moment? And the question that everyone will want to know as well, what are the associated costs?
Yeah. Oh, right. Yeah, that's so. Okay, so there are two types of robotic exoskeletons in terms of upper limb. There are, as I mentioned, the tethered ones. So these are fixed stations, and these devices are usually used in clinics, in rehab clinics, because they are so big, and there is you can wear it, but still you are attached to that fixed station. And there are a number of these. So there is one produced by Hokoma, which is a Swiss company, both at the moment, I think it's bought by a Chinese company. So they've got their Armeo, and again, this is a fixed station, and the person can put their arm and have a prescribed number of exercises to do their rehab. There is another company called Tiro Motion. I'm not sure if I can mention the names of the companies. So, and these are. Some of them are available in some clinics and in the NHS as well. But again, you have to go to that clinic to do the exercises and to have a rehab program. The untethered ones, so the ones that you can take home, for example, and do your exercises at home. To the best of my knowledge, there are two at the moment commercially available. One is called Myomo, and one is produced by Cyberdyne in Japan. Myomo is produced by an American company with the same name, and the Myomo is available privately in the UK. There are distributors that are selling it. The Japanese one is not. So at the moment in the UK, there is, I think, to the best of my knowledge, there is only one available. In terms of costs, they're not cheap, I'm afraid. So they are in the range of $30,000.
Wow. So there's nothing available that you could purchase privately unless you had the money to do it. Obviously, there's no. As you mentioned there, the NHS have some resources, but you've got to go in clinic to use them. So they're for people that couldn't afford to purchase something on a private basis, they can't have that
Yeah,
of provision at home?
Yeah, I mean, the stationed machines or the tethered ones are even more expensive than that, than the untethered ones. But yeah, the price at the moment is prohibitive, I can imagine, for most people. And it's the myoma is not available on the NHS. It's not. But currently, as you mentioned, we're working with Stoke Mandeville, a scientific research charity, and we've got a project with them to assess the efficacy of the myoma upper limb exoskeleton in the rehabilitation of spinal cord injured survivors. And we're working with the Robert Jones Agnes Hunt Orthopedic Hospital in Oswestry, and with Glasgow Spinal Cord Injury Unit to assess this technology with their inpatients. So this project is still ongoing, so we're not released the results just yet.
But will you let us know, hey? Because I'd love to know when the research is published. Please let us know.
Of course, because we will be publishing this in articles, and we will let you know, of course.
That'll be great. I mean, it's such a useful reminder for us to think about, because, you know, as a lawyer with clients who have sustained catastrophic injuries, lots of them neurological, it's something to kind of bear in mind. It's something to explore, isn't it? I know that it's difficult, and there are lots of ways that it's going to be developed, and it's not quite there, and it's very expensive, but it's something to look into, isn't it? It's still possible for it to be integrated into an individual's rehab now.
That's true, yes. But the price is not for everyone.
But the price is not, absolutely, And if there is some private funding in place, you know, if someone has a case ongoing, there might be some funding there. So it's worth just bearing in mind. I'm thinking out loud, really, but you're giving me stuff to think about. And in terms of, and we're running out of time, this always happens, Heba, but in terms of when this technology does become hopefully a bit more kind of readily available and development kind of continues, how do you see it having a kind of long-term benefit for people, you know, with their rehabilitation?
I think it's very, well, the hypothesis is that it is very useful to do because at the moment all the rehabilitation programs, all the patients are underdosed basically in terms of upper limb rehab, and that will offer them you know, an opportunity to take ownership and manage their own rehabilitation, take ownership of their own condition. These devices also have data loggers, so it can log the progress and can do a lot of clever stuff in calculating different performance measures that can be shared with the clinicians. In Liverpool, so my research group are developing a more affordable device, and if we get the required funding, hopefully in 2 or 3 years, we'll have a much more affordable device that have even more degrees of freedom than what is existing at the moment, and would enable more people to use that technology. So and make it readily available for the NHS. So hopefully that would happen.
Goodness, it's a long old road, isn't it? But I mean, just thinking about you know, my own clients and the potential independence that it offers to people, just even like, you know, it would be so significant for somebody to of course. I mean, and the change in quality of life, if they are able to, you know, button their own shirt and you know, have their meal themselves and so on, give them a lot of independence, as you mentioned, and improve their quality of life. So that's a huge confidence boost as well. Oh, well, thank you so much, Heba. And I have to say, when we spoke before, I was asking Heba about kind of what this technology looked like and whether I could see it in practice and whether there were any videos I could look at, and she sent me 2 absolutely amazing videos. So I'm going to link them on the recording of this webinar, so you'll be able to click on them if anybody specifically wants me to email it to them, or wants any more information, please drop me an email and I'll be very happy to pass it on. Definitely well worth a watch, and I'll also post the links to all of the things that we've mentioned, the charities, the organisations, and if anyone wants any further info, you can always contact me. Heba's email as well will be on the end slide on the recording. So feel free to drop us a line, and thank you ever so much, Heba, for talking to me today. It's so useful to kind of turn our minds to this stuff that's often, you know so much, as I said, about the lower limb stuff, and it's really useful to be reminded about the progress and the development of what's going on with the upper limb stuff too. So we're super grateful to you, Heba. Such an interesting chat. Thank you.
Well, thanks for having me and giving me the opportunity to share this information with your clients.
No, it's a pleasure. Thank you, Heba, and thanks everyone for tuning in, and we'll see you again very soon. Take care.
Bye.